Welcome to 13 Cubed. In this special episode, I'm joined by Mike Peterson of nullsec.us. Mike has actually been a very frequent contributor to the channel. In fact, I think the largest viewed video on the channel, which is Introduction to Hashcat, is a video that he authored and helped me make. And he's also been contributing to some of the 13 Cubed courses. So if you've taken the newest Investigating Linux Devices course, the final challenge in that course was actually designed by Mike. And if you haven't, well, go check out those courses at training.13cubed.com if you're looking for quality forensic training. Okay, so this episode is all about Shimcache, also known as AppCompatCache, also known as Application Compatibility Cache. So it's the artifact with three names. It's also the artifact from hell, or at least that's what I call it, because it is very, very confusing. There are a lot of gotchas, a lot of caveats, if you will, with this particular artifact. So what I would like to do first is go through and talk about the basic information, the artifacts, as I generally call them, which are like the nutrition facts for an artifact. So let's go through and talk about that. And then once we've done that, I'm going to pass it over to Mike, and he's going to talk to us about some of the new research he's been doing regarding Shimcache and how some of the things I'm about to tell you are going to come into play, because I do have some information here that is probably going to be new news to you. Okay, so let's start with the basics. Shimcache was put in place for the ability to provide backwards compatibility with older software. If you think about the definition of a shim, you might think about a little piece of wood, like for example, maybe you could shim a window or a door or something that wasn't closing properly. Well, Shimcache basically means that we could shim an executable, which means basically to apply extra settings or configuration to that executable to make it run on a version of Windows other than which it was originally designed for. So maybe you've got some old piece of software that was written for Windows 2000 or Windows XP, and you're trying to run it on a modern Windows 11 box. And, surprisingly, that kind of thing works and happens all the time. And in some of those cases, Shimcache can help with that compatibility layer. So that's the original purpose of it. I like to say that in forensics, almost everything we call a forensic artifact in Windows was not put there to be a forensic artifact. It's generally something that supports either something that provides backwards compatibility like this, or something like prefetch that is designed to make the user experience better. So this is going to be, again, something for backwards compatibility. Okay, as far as where is it stored? Well, that's going to be in the system registry hive. That's the location of Shimcache, in the system hive. And there are a certain number of entries that can be tracked, a maximum number that can be tracked depending on the operating system version. So in Windows XP, we had 96 maximum entries within the Shimcache. In other words, 96 binaries that could be tracked. In Server 2003, that number increased to 512. In Server 2008 and later, the number increased to 1024, and that's still the case for modern Windows Server. And then in Vista and later, that number is also 1024. So that includes all the way up to Windows 11. So 1024. Now, the important thing to keep in mind is this is stored in the system hive, as I said, and it's under the control set. So on a live system under current control set, recall that you can have multiple control sets. So if you had two control sets, control set 001 and control set 002, you may have a maximum of up to 2048 entries that could exist in the Shimcache. Essentially, you have a copy of that Shimcache database per control set. So keep that in mind. The other thing to know is it's not just C:, it's not just the boot drive or the Windows drive, which, by the way, is referred to as sysvol by Shimcache. It's not just the C drive, but also network drives like mapped drives, UNC paths like, // IP address /C $, USB drives, and, whether it's an external hard drive, a thumb drive, flash drives, all those things can end up being tracked in Shimcache, which is pretty awesome. Now let's talk about some of the caveats, all right? In Windows XP, it was pretty easy to tell that something executed by virtue of it being in the Shimcache, because if it was in the Shimcache in Windows XP days, then it executed. And that was fine. But in Windows Vista, all the way through Windows 8.1, you would end up having things in the Shimcache that weren't necessarily even needing to be shimmed. So then the question would become, how would you determine if something executed based on this Shimcache artifact in Vista through Windows 8.1? And the answer is via what's called an insert flag, which the forensic community dubbed an execution flag. So if you're not familiar with this, let me be the first to tell you this was never an execution flag. It was never called that. It was never put there for that reason. But it was true that if you had an insert flag that had a certain value that you could tell based upon that value that basically this thing had executed. So that was something good to know. And we just knew that if we enumerated the value and we had an insert flag that was equal to this particular value, that it likely executed. And again, that was true for Windows Vista all the way through 8.1. But then we got to Windows 10, released in June 2015, and the insert flag was gone. So what we said, and what I said in one of the videos that I made about Shimcache, was that it is not possible to determine if something executed via the Shimcache on Windows 10 and later. And that was the guidance that we always provided. In fact, in the Let's Talk About Shimcache episode, that was actually focused on quite a bit, that you can't determine execution. And that was true, except it's not true, not any longer. Because in March of 2023, some research was performed by Eric Zimmerman, author of many of the tools we use, and he actually determined that there are some additional bytes, 4 bytes in particular, at the end of each Shimcache record that, if equal to a certain value, in this case, that value being 01000000 or 1, that thing likely executed. And so Mike's going to talk more about this when I pass it over to him, but basically we've done a lot of testing, and it seems to hold true that if that value is set, that whatever you're looking at did in fact execute. But of course, there's a caveat. This only applies to non-native Windows binaries. So we're not talking about things like cmd.exe and PowerShell.exe or regedit or things like that. We're not talking about those. We're talking about non-native Windows binaries. So threat actor drops a.exe on the system. Well, then if a.exe was executed, it probably is going to have that value of 01000000. And then if you use Zimmerman's tool, which is called AppCompatCacheParser.exe to parse the Shimcache, then you're probably going to see a yes next to that binary. Yes, it executed. So that's a very interesting takeaway, and something that we certainly didn't have the ability to do until this AppCompatCache update, which actually was in March of last year, March of 2023. So it's not like this is something that just happened. But the crazy thing is, and the reason why we're making this episode, is that most of the forensic community, and up until recently, myself included, Mike included, were not aware of this. We're not aware that AppCompatCacheParser had even been updated. Maybe you ran it and you saw that there's no more NA, there's a yes or a no, but you might be thinking, how is that information being derived? Well, there's your answer. It's being derived based on those last 4 bytes. So very interesting. The other thing, just to finish up the discussion here, cache entry position is another very important thing that's associated with Shimcache. Cache entry position starts at numerical value 0, which is going to reflect the most recently shimmed thing. That's generally going to be at the top of your list in the Shimcache output. And then as the numbers increase, that's further down the list, which means less recently shimmed. Of course, the big other caveat is that Shimcache is only written on reboot or shutdown. So keep that in mind. It is possible, by the way, to obtain a memory capture, a full memory dump, and parse Shimcache out of memory. And I will tell you, this is new news as well, is that the newest development build of Volatility 3, if you actually do a git clone from the repo, there is a Shimcache plugin that apparently has recently been added. It's in development, and it's not in the release version as I'm recording this. It may be by the time you're watching this, but it does seem to work. It does not parse this flag that we're talking about, or these last 4 bytes. You'll see an NA for everything on modern Windows systems, but at least you can use Shimcache for what we always said you could use it for, which is evidence of presence or evidence of existence of a file. So just note that windows.shimcachemem is in the newest development build of Volatility 3 and can be used. Okay, so now that you know all of the caveats, what I would like to do is pass it over to Mike, because he's going to walk us through the blog posts that he has created on nullsec.us that highlight his testing. And I think there are 3 different blog posts right now that he's made. There probably will be more in the future. but he's going to walk us through that. So I'll go ahead and pass it over to Mike.
Yeah, thanks, Richard. So yeah, like you said, this was something that for years I had looked at as we can't prove execution in this. And while I was updating some of my internal documents, that I might turn into another blog post, kind of a cheat sheet on AppCompatCache, I noticed that running it on the newest version of Windows would give me that yes or no value. And it really got me thinking, where did this start? Was this a change to Zimmerman's tool? Was it a change to Windows? And if so, how long has it been around? And this has been around. It's been around since the beginning of Windows 10. So it wasn't a change to Windows, not a recent one anyway. It isn't the same as the insert flag. It's a new value that's been put there. And digging into this, share my screen here.
Yeah, I'll repeat what you just said too, just so everyone catches that. You're saying, correct me if I'm wrong, but you're saying that you did pull down the Windows 10 RTM, the actual release to manufacturing version of Windows 10 from June of 2015, and you're saying these bytes are present at the end of a Shimcache record, even all the way almost 10 years ago.
Yep, the structure has changed very little since then. The header of the Shimcache entry has changed a little bit. A few bytes were added, but the basic structure that you see up on my screen here has remained pretty much the same. So it kind of starts with this 10TS header here for every entry, and then most people are familiar with the path name there. And then these last couple of bytes down here at the bottom, you can see that one 01000000. So this has been something that's been executed. And now in these, they label that as padding, but Zimmerman was actually looking at those 4 bytes, all 4 of those bytes there, to determine whether that's an execution. And there's multiple values of this, so it's not just one, but anything other than 1, he says, indicates not executed, or is labeled as a no in the executed field.
Very cool. So you're actually looking, what you're showing on screen now is his code from AppCompatCacheParser, right? So you can see the comment there, and you can see that he, like you're saying, is looking at all 4 of those bytes, looking for a value of 1. But you're saying that there are plenty of other values that could exist besides 1, right? And we don't know what those are necessarily. So.
Yeah, I've seen, I think, 5 others. So yeah, going through parsing this out, there's if anybody wants to follow along with this, my first blog post has the template that I used in 010 editor. You can grab your own Shimcache, use this to color code it nice and neat, and you can look at the values yourself. The second blog post that I made, you mentioned there were 3 of them. The second one is kind of a side quest into building a custom version of the AppCompatCacheParser so that you can get the actual values in that executed column field, and rather than just the yes or no, so you can see what value is associated with a particular Shimcache entry.
Awesome.
And then what I found was, so there's at least 5 entries, like I said. There are some, like you said, caveats to this artifact. One of the first things I noticed just right off the bat when I started my testing was 7zg.exe. When it was executed via the right-click menu, it didn't show as execution. When I actually drilled down into the folder for that executable and double-clicked on it, then it changed to 01. So this is where we kind of get into how trustworthy is this artifact.
Indeed. So what you're saying is, like, if you right click on something in Windows Explorer to bring up the contextual 7-zip menu and execute it that way, you're saying that it doesn't show execution, but if you invoke the binary through Explorer, like double click on it or whatever, then it shows up as executed?
Yep, correct.
Yeah, that's pretty wild.
Yeah. And there were a few other artifacts that I found like that. Firefox private browsing.exe, I couldn't get to show as executed at all. So, if you're working a case where the question is, was this individual browsing in a private window and this is your only artifact, you wouldn't be able to say one way or another. I wouldn't be able to testify to that.
Makes sense.
Yep. So There were a couple of other outliers here. Mostly, though, what I found was that if it is a user executable, not a native executable, not something out of C Windows System 32 or another Windows directory, it was pretty reliable that if it said yes in the executed, that it was something that had been executed. On the other hand, if it says no, if it's a system binary, you probably won't be able to tell one way or another. If it is a user land binary, it gets harder to tell because you have some of these caveats like this, and without some testing in that environment, you really can't be sure.
So let me repeat what you just said for everyone listening. So basically, if you see a yes, then the confidence is pretty high that that binary executed. But if you see a no, the confidence is pretty low that that binary didn't execute. Would that be a correct way to say that?
Yes.
Okay, so that's a good takeaway there. I think honestly, it might make more sense in the future. If it just had a value of yes or NA, it almost seems like yes, it executed, or not sure, insufficient information to determine. That might be better, in fact, than just yes and no. But yeah, that's interesting. The thing that I worry about is that I don't want someone in a scenario like, let's say you're investigating a Windows server system, okay, and you don't have prefetch, which is one of our most high fidelity evidence of execution artifacts. And let's say that you're looking for PowerShell usage because that's key to your case. You have to determine whether or not PowerShell was launched, and you parse the Shimcache from this Windows server box, and it says no next to PowerShell. So you say, no, PowerShell definitely didn't execute. But obviously the problem with that is what we've just been talking about, right? The problem is that that is a native Windows binary, and therefore that execution would not be tracked. That's a caveat. So you have to be very careful with that. You have to say, there's insufficient evidence to determine one way or the other in that case, again, as of our understanding right now, right? But makes sense.
Yeah, it's definitely better as a data pivot point. So if you see a binary in there that's listed as yes, try to find another way of proving that, prefetch or maybe a Windows event log or something like that, because it gets hard to tell.
Yep, exactly. So I guess the takeaway, the advice here would be, while it is possible to use modern Shimcache to determine in some cases whether something executed, always try to corroborate that with another artifact, and just take it with a grain of salt and realize that this information may change. By the time you're watching this, maybe we've learned other information. Maybe you're watching this a year after we've recorded it and we've determined what some of these other values mean. And it's one of those evolving things in terms of our understanding. But like Mike said, the crazy thing is that this has been in place for almost a decade, since Windows 10's original RTM release back in 2015. So pretty wild. So be careful with this artifact. In my opinion, probably in Mike's too, I won't speak for him, but I think this is best served as an evidence of presence or evidence of existence artifact. That's what we've always taught people anyway, and I think that still remains the case. Use it for that. That's going to be very, very important. Yep. All right. Any other thoughts or comments there, Mike?
Nope.
All right, excellent. So,
yep.
Yeah, so I hope you guys found this look at Shimcache very interesting. Remember all those caveats, and of course, I didn't mention this, but remember the timestamp. The timestamp always throws people off, especially people new to Windows forensics. That timestamp is not the time something executed, if it even did execute, and it is not the time something was shimmed. It is the M time, the M in MacB. So the modification timestamp is literally what that time is. So just keep that in mind. That's really important. If you want even more in-depth information, check out Mike's blog posts that he has. They'll be linked in this video's description. And also you can check out the original Let's Talk About Shimcache episode, with the exception of saying that there is no way to prove execution in Windows 10 or later. Again, everything covered in that episode is still valid. It still works the same way, like when you resize the Windows Explorer window to determine what executables are present, and that ends up affecting what's in the cache. All of that works the same exact way. Everything works the same way. It's just that we now have this other way of potentially determining whether or not something was executed. All right, so that concludes this 13 Cubed episode. I know this was a bit different, kind of an interview, more casual style, not scripted or anything like that, but I hope that you find this information useful. I'd like to thank Mike for joining us. Be sure to check out his blog, nullsec.us. There's lots of good information there, and we have lots of collaboration things that are going to happen in the future as we continue with YouTube videos and with 13 Cube training courses. So Mike will continue to contribute to all of those things, and we appreciate him being here on this episode. And that does it. So thank you for watching. Thank you for subscribing, and I will see you in the next 13 Cubed episode.